Hello everyone, I am Professor Caudill. Today we are on 76. We got 5 left in this chapter. So let's get right to it. Air traffic controller noticed 2 signals from 2 planes. So 2 signals. One plane is at 800 meters. So one's at 800. $25 southwest. Okay. So we're given a Z magnitude, an X magnitude, and the angle of Y. So plane 1 is 9.2. So this is a tough one because it's kind of, I know how to do it in 2 dimensions. But I want to get some help. So I haven't really used this before. C squared equals A squared plus B squared minus 2AB cosine C. So it's like where does this come from? Why do we add this? Why do we add this? Y is negative 2AB cosine. It's not an alternate, but rather an expansion of the law of cosine. So it's not the Pythagoras theorem, but expansion. Um, so this is for non-right triangles. So I guess that's the key word. Non-right triangles. And C squared equals A squared plus B squared for right triangles. C is the length of the C is the length of the side opposite angle C. Okay, so C is in a triangle with sides length. Okay, so it's saying if this is C, A, B, So I'm thinking this is C. Angle C is between A and B. No. The angle opposite side of C. Okay. Don't really know what it's talking about. Maybe we'll learn about it later. So, okay, so C is the distance between two planes in 3 dimensions. First, let's find the distance the plane makes with respect to the tower. So they're saying the distance between the tower and P1 okay, we know how to do that. I think, no. 25 degrees. What does it say? 25 degrees south of west. So that's 180. So ChatGPT doesn't understand like how to correct that. 180 plus 25. 180 plus 205. Okay. So that'd be our x component plus 19.2 sine. Okay, and then we could just do the same. Distance from P2 is I think that's 20 southwest, 20 southwest. 200. So you see I'm really loosely using the language model. It's like it's good for spelling it out, but anything specific, it's good for generalities. So okay, so what's the distance between these two? So that's going to be the distance between these two vectors is the square root of x2. So it's going to be this minus that. So it's going to be some number plus 17 some number plus 8. So negative 17. Okay. So 2 squared, 4 squared. 2 squared is 4. Square root of 4 is 2. So it's 2. I'm guessing it's in kilometers. I kind of forget. Okay. 2 kilometers. I'm not even considering any of this. 2 kilometers. If we're wrong, we're wrong. Let's move on. Um, show that A, B, C. Okay, so where do we want to start with this one? Let's say 1, 1, 0 plus 0, 1 equals 1, 1. Okay. Show that when this is true, then magnitude of C, then 1 equals, so this would be 1 squared plus 0 square root. One plus 1 plus 2 cosine that 1 equals 2 plus 2 cosine phi. So the angle between these, so we need to find the angle between this A and B. So what's the angle between A and B? We do cosine theta is A, it's gonna be A dot B, so it's gonna be 0 plus 0 0 over stuff. A dot B is 0 plus 0, so 0. So theta is cosine -1 of 0. Okay. 2 times that is 3. So what am I doing wrong? Maybe I have the formula correct. So c squared, the magnitude of c, the magnitude of this is 1 squared plus, or it's 1 square root of 2. So that's the magnitude. So it's saying the magnitude squared, so so it should be 2, I guess. 2 equals 2, so it could be 1. I wonder if there's a way to get it to be 1. So I have a dot b over 1 times 0 is 0 plus 0 times 1, 0. This makes sense if it works out if this cancels out. I need this to cancel out. So let's try calculating it. 1, 0, 0, 1. Okay, we're looking for the angle between A and B. It's 90 degrees. So A and B is 0. Theta equals 0 degrees. No, the theta should be 90 degrees. Okay, what's A? Square root of A dot A. Square root A dot A. 1. So say the square root of 1 times okay. Let's try cosine and 0 over 1. Sometimes it's kind of weird like that. So I guess you want 1.5. Same answer. All right. Go. Okay. Why is it got a negative sign here? Okay, so I guess if I convert it to degrees, then it makes more sense. A cosine of 0. So then, okay, so then you plug in. Okay, so I think I get what we were doing. So if a cosine is that, then we're taking the cosine of that, which is 0. Okay, that makes sense. So our final answer is 2 equals 2 plus 2 cosine equals 2 equals 2. Okay, so I did a special case. Hopefully that's good enough for you. 78. Four force vectors have the same magnitude f. Okay, so f1 equals f uh, f cosine equals what do I want to do here? Uh, I want this subscript to kind of vary. So we're gonna do I k plus f sine ik. And then the y component, that is the y component. What is it? And if you want, these are the unit vector. Okay, so what is the largest magnitude of the resultant vector force? Okay. So resultant is going to be some magnitude times, let's call it F1, direction of F1 plus some direction for F2 plus magnitude times some direction of the force of the third force, and then F direction of the fourth force. So it's going to be 4F. No. Yeah, so it'll be 4F sum of the direction, these directions. So the largest magnitude is 4F. That's all I can really say. I'll put in the language model for any possible enlightenments. Okay, so we got 4F, right? The minimum is, so that's, minimum is where I had issues. Minimum is still 4F. I guess we can try this. Why not? All right, yeah. I don't really like that. It's not pretty. Just personal preference. 79. Got 30 minutes. Maybe we can get through these. I don't know. Skater glides along a circular path. So we have a circular path. Skater glides across it. Radius of 5. In a clockwise direction. When he coasts around one half the circle. Okay, so I think we're about half the circle. So starting from the west point. Okay. The radius is 5, and the diameter is 2 times the radius, so it's really 10. The reason I'm saying this is polar coordinates, it's on the x-axis. So the radius, it's a circle on the x, centered on the x-axis, so the radius would be 5, but we're going to cross it. So the whole path has a diameter of 10. So maybe it's saying when he starts here, when he goes around 1/2, so when he goes 180 degrees, so 5, 180. So polar coordinates is going to be 5, 180. They want its magnitude. So if we want to find its magnitude, we first convert this into uh, polar coordinates. Polar, where's polar? Well, something like this. Point 1 converted. Okay, I want to know if this is Okay, so xy is p. So the what do I want to say? Cartesian coordinates is -5, 0, which makes sense. Okay, so this is displacement vector. So it's going to be 5 meters. Is the magnitude of his displacement vector, and how far has he actually skated? How far has he actually skated? Okay, so if he starts at 0 degrees 0, starts at the origin. No, he starts at 5. He starts at. No, he starts at 0. Hmm. All right, I want to move on. Um, let's see. A stubborn dog is being walked on a leash by its owner. It's the magnitude of the pulling force. So 98, 132, 32. Think what the magnitude of that. Oh, it's going to be newtons. Um, okay, what angle is making the vertical? So I think we do that. So 132 divided by 168. 0.8J. So if J is like that, then we're taking 0.8J, like that. So it's going to be 168.8J. So that's kind of hard to see, I guess. So like if this is the X and Y, and you know the vector, if you want to know the angle between these, you do TOA, so I'm gonna move on. If the velocity vector of polar bear is u, okay, so it's going negative 18. Okay, so the speed should be the magnitude of the components. Equals polar bear and kilometers an hour. And what direction is it heading? So is going this way. We want to know this angle. Um, maybe maybe I could do this. -18 dot that wouldn't work. Given y 22 adjacent -13 121 degrees. It's not right. Okay, I see. We could drop the opposite here. That would be -13 over 18. 216 degrees. So that'd be 260 minus 180. 36 degrees. Okay. All right, so I think we solved that one. Let's return to the stubborn dog. So maybe I should just draw this out. Let's make a simple version. Let's say this is 10, 13, 3. Okay. C, X, Y. So we have 10. 10, 13, 3. 1, 2, 3. Okay. 1, 2, 3. So our force is going that. So we want to know the vertical. So obviously there's a theta xy, and then there's a theta yz. So it's saying if we know y is 13, z is 3, we want to know this angle. Okay, it's saying the angle is tangent equals opposite so this would be adjacent, this would be adjacent. And you draw this in graph it in a way that makes the TOA okay, so it's we have this. We want to find the angle theta. We know it's 3 and 13. So we know this is 13. No, we know this is 3. This is 13. So we drop this. This makes a right triangle. Okay, so now this 3 is our opposite, so 3 over 13. Okay, so 3 dimensions are kind of tough. Vector 10, 13, 3. So what did we get? 22? No, that's for the last problem. So we got 16 that we could easily calculate that. So that's 16. Okay, so it's saying okay, so yeah. So now I get it. Now I can get the language model to do what I want. First time it didn't exactly do that. So um so I think we've kind of described it somewhat better. So you have to kind of like look at this in a two-dimensional way. And here I should have drawn like a vector, then capture that we're taking a side image of it. So you have to think like we're kind of like there's kind of like a x-axis here that's directly aligned with our perspective. If that makes sense. Um, yeah, I think we could have got this if we maybe just better at drawing pictures, but and we should remember the tangent, the TOA when you need to find an angle. Uh, Magnitude, we didn't even need the magnitude for this. Okay, so next time we'll pick up at 82 and we'll be still in 3 dimensions. So thank you guys for hanging out. I'll see you next time.